yeah, why Bitcoin will trump blockchain for enterprise cloud storage or cloud services in 2020. So this is our second webinar. I've left a couple of intro pages about us. So we are a management consultancy. We help businesses build communities, improve productivity, leverage emerging technologies, and we are one of the first companies in the Asia Pacific region to offer Bitcoin SV exclusive integration services. So that's us at Fire. That's me. I'm the head of technology at Fire. I'm also training development manager for the Bitcoin Association, CEO and founder of Coin Storage, one of the original creators of the tokenized protocol, a Bitcoin scaling proponent, and developers of the Satoshi Shotgun, which is enormously fun. I apologize. I do have notes that I'm using and they just completely disappeared on me. Let me get them back up. Okay, there we go. So, what is blockchain? Last time we started with a question about what is Bitcoin. But in this webinar, I want to go over the concept of what a blockchain is and how the blockchain is used in the case of the Bitcoin ledger. And then also to look at some of the other things that are happening out there and why, in my opinion, they are not the correct way forward for the industry. So what is blockchain? You would think that the seminal document that describes the first major instance of a blockchain in a public ledger would at least talk us through what a blockchain is. But as you can see here, the word blockchain isn't used even once. And trust me, I tried it with and without spaces. We do see the words block and chain, but never together like that in the white paper. So this is because the blockchain is nothing but one part of the mechanic used to build a secure public ledger with its own integrated peer-to-peer cash system. And the white paper does talk about the longest chain of hash-based proof of work, and that work is embedded into blocks in a blockchain by the miners who work to secure the network. And this is what enables some very important things to happen with the data that's stored on the ledger. So, and in fact, Satoshi describes that the action performed by the nodes is more of a timestamp server rather than a blockchain node. So they are taking real-world actions, applying timestamps onto them, bundling them into blocks, and then sharing those blocks with the other miners on the network. But the fact that it is a blockchain has very, very little to do with its functionality as a public ledger. And in fact, it is, I think, interesting to note that you could go back and change one bit in the Genesis block and change the block header of every single block that's ever been found on Bitcoin, but it would not change the transaction ID. If everybody used all these Coinbase transactions back since the very beginning of Bitcoin, we could have all of the same transaction IDs, but a totally different set of block hashes. So that just goes to show you that the two systems, the actual transactions that you do on the network and the generation of blocks themselves are completely separate. They really don't have any bearing on one another. So, and I think that's something that gets very lost in the weeds out there. So just to have a quick look at what goes into blocks. So firstly, we have the block header, and this is where miners include a link back to the previous block that they are building upon. And so this is how miners have their say on, or have their vote on whether or not a block is valid. And they do that by choosing whether or not to build upon it. And they have the freedom to choose not to build on any block for any number of reasons. And that can be, they don't like the color of your hair, they don't like anything. Like it doesn't necessarily mean that it's an invalid block. You might be doing things that their node is not configured to handle, using really huge transactions, chaining too many transactions together. Who knows? So it's really upon the players operating within the network to figure out how to compete with each other within that paradigm. So also then included in the header is what's called the Merkle root. And so the Merkle root is the root of a tree that is an aggregate marker that can only be created by mathematically processing the transaction IDs of every single transaction in that block together in exactly the right order. So Merkle trees were first patented in around 1979. And they've been used in a variety of different stuff, including file systems, revision management, and really any system where immutability and certainty that a piece of data has not been changed over time is a desired feature. And the advantage of a Merkle tree is that the entire structure can be tested against a known Merkle root, which is just 32 bytes long. So it doesn't matter how big our blocks get in Bitcoin, we can always test any block against a 32-byte Merkle root. And as long as we have access to all of those transactions, we can calculate all of the transaction IDs, put them together in the correct order, and perform the block hash function. And with the nonce that the miner finds, we can validate the Merkle root. So that's one of the genius aspects of what Satoshi put together when he built this, is this means of being certain about what was valid at any given moment. Merkle tree of a Bitcoin block is made using the transaction IDs as leaves in the tree. The transactions themselves are not actually part of the structure of the Merkle tree. So I don't know if a lot of people know that. The only part of the transaction that goes into the Merkle tree is the transaction hash. You do need the transaction to create the hash, but once you have the hash, you can discard the transaction. So this is an aspect of pruning. But if you change one bit anywhere in the whole thing, the entire Merkle tree changes. So this is definitely part of the immutability. So why are blocks useful? So blocks are a function of the competition between miners for gathering transactions together and creating blocks. And the reality is that users of a public ledger do not need to wait for blocks to work with the information on the ledger. So you don't need to wait for an inbound transaction to be confirmed to spend money. It has a 5 transaction chain limit, which means that you can on-send something 25 times before the next block is found. But pretty soon this limit is going to be basically lifted and allowing miners to set their own limit on that value. And I have it on very good authority that the guys in the scaling testnet are already pushing the boundaries of what they can do, and some very exciting things coming out of that. So the animation that I'm showing here is the spread of a transaction across the network. As you can see, it goes from wallet as a signed transaction to a peer. And the peer then analyzes that transaction, and if it's valid, propagates it to all of its own peers. And after around 2 seconds, the network as a whole is aware of your transactions. So at this point, anyone receiving money from you would be aware that they've received it. You can continue to send your coins in as many chain transactions as you like without worry, because it's only the information going from you to your peer to the rest of the network. And as long as you're not double spending your own coins, you can just keep chaining transactions together. So, and this is the same for users as for apps. Apps using Bitcoin SV will be able to send and receive as many updates as they need without waiting for blocks. The block mechanic should be kept completely separate from the user experience. So, assuming that you have the right peering methods being used, you should always be very quickly aware of anything that does happen to your account. But we also see applications where that's not so required, such as kaching cards, which are basically an offline card. They need knowledge of something that they control before they can transact with the network. And they don't necessarily get to see updates every time they create a transaction. So they're a pretty interesting difference to this animation. But the reality is you don't get to pick which block your transaction is in. You can specify a block before which it cannot be mined, but you certainly can't say it must go into a particular block. That is completely up to the miners. All you can do is submit your transaction to the network. So now at this point, we've established that blocks are really merely a convenient way to gamify the attachment of recent transactions onto the ledger in an immutable, simple, and efficient way. And if you were doing this in private on a centralized server, using a blockchain just makes your life many times harder. There are much more simple and efficient ways of doing this that don't involve a blockchain. So it really is not about blockchain. Sorry, but there we go. So what I wanted to do now is look at a couple of scenarios. One where we have a single common public ledger being used by everyone, allowing messaging, finance, and more on a single network globally, versus a system where we have many blockchains for many separate purposes. And so in this example, we're going to look at an airport. And as you can see, all of the services, all of the people, the staff are using Bitcoin for their messaging. When passengers check in and drop their bags, their wallet sends a message to the ledger, which tells the airline, terminal services, immigration, their insurance company, that they're in the terminal, that they've checked in. And having a single ledger actually assists us in our security model by pushing the boundary of all of the encryption and everything right up to the device, and everything goes directly from the device to the public ledger. So it makes it extremely difficult to insert a man in the middle when there is no middle, because there's no server. One user talks to the network, another peer reads that information from the network. So when we do start talking peer-to-peer, because everything is inside signed transactions in payment channels, again, we still have that same security where it's impossible for a man to sit in the middle and then actually sign without knowing somebody else's keys. So we have extremely good security. It's very everyone looks at the same database for all of their information. And so now every wallet, kiosk, terminal in the airport now becomes a BSV wallet, basically, a BSV device. It's watching the addresses controlled by a certain set of keys, seeing information come into it and reacting. And we now no longer need these devices. So currently in airports for check-in, you have devices that are going back to central servers in Europe, in the US, every time somebody checks in. Well, now they only need to go to the local copy of those transactions on the ledger. And everyone sees the ledger at once all over the world. So, and once we, the same thing happens for peer-to-peer. So it doesn't necessarily mean that all communication via the network, signatures, and all the data protection is happening inside the Bitcoin protocol. So there will exist secondary systems that sit above the ledger and augment people's user experience. And this is much like what we're already seeing with Handcash and MoneyButton. They have their own servers that do certain things, but it is still the user's direct interaction with their own wallet on their own device that is signing all of their information. So, and in this, what this scenario allows is for a user to have a single identity across all of these services. So because their identity is on the ledger, It can be attached to a public key, and it will allow that user to have a common identity across all the different services, and using a single alias on one network to access all of these services. And this can still be done with a very, very high degree of privacy. Another important aspect of this is that for all of the systems that are using the network, the responsibility for the infrastructure and the security of that data and the longevity of that data is actually now no longer their responsibility. That is pushed down onto the miners who are building the ledger. And so it's only through many, many years of uninterrupted performance that reliability and the certainty of in the network will grow. But we're already there now. It's been I think 6 years or 7 years since the last major problem with the network. The uptime is incredible, and it's only getting better and better. So in this scenario, we have a situation where the user is storing their own data on the ledger. So corporations really get to walk away from any systems that have them storing people's private information on their own servers. So, the ledger gives us a lot to like. So now let's look at this same scenario, but in a blockchain world. So as you can see now, we have separate blockchains for the airline. We have separate blockchains in each company in each country to manage immigration. We have a separate cash blockchain. We have a terminal services blockchain that is managing gate assignments for planes and where the luggage comes out and all of this sort of thing. We have a separate blockchain for the travel insurance and a separate blockchain for hotel points and bookings. And so when a user tries to interact with this system, all of a sudden they need to have separate identities on each of these different blockchains. Now, those identities can be generated from the same master keys, but they do need to be replicated on every single one of these blockchains. So they have to have an identity on the airline chain. They have to have an identity on both of these immigration chains. They have to have an identity on chain, insurance chain. Now we start adding more users. So for the airline staff, they need to be able to talk to the airline chain. They need to be able to talk to immigration. They've got to be able to talk to terminal services. The terminal has to be able to talk to the hotel and the airlines and immigration. And government and customs needs to be able to talk to everybody as well. And what you soon end up with is a giant mess where so many links are having to be maintained by all of the users of the system. You would literally have a collection of 8 or 10 different wallets on your mobile device just to get through an airport. And it's bad enough as it is right now that you have a separate points app and Wi-Fi and everything when you go through the airport. But now you end up in this nightmare situation where you are actually having to connect to several different networks at once. And look, it is potentially possible that somebody could step in and write a system that makes this very streamlined and easy. However, the back end of that is going to be so complex and having to deal with so many things changing and moving all the time. I simply don't think it would be practical. So, I believe that using these multi-blockchains in this manner is not feasible in real life. It simply does not represent an efficient means to conduct business. So, what about cloud services? And so cloud services, I would say, is when data is processed, organized, structured, or presented in a given context, such as to make it useful or to turn it into information. And if you came to the last webinar, you would have seen this slide. And it tries to show that we live in a sea of data. We're constantly exposed to data. Our reality is data. but this data can be filtered and presented to create information. And information I would classify as an organized subset of data. And it's through information that we build knowledge. And so having a single common ledger upon which we are arranging our information becomes very useful to everyone. And it even becomes crucial to achieve some of the new things that we're going to need to do. But with a fully scaled ledger, all of a sudden we have a means to bring all publicly available data into one place. This includes science, patents, government, environment, and much, much more. So now, while using Bitcoin as a cloud layer might sound expensive, and it currently is expensive versus traditional technologies, it isn't hard to see that within a few years, the cost will fall and make ever more diverse business models possible. So, currently it would cost around $5,000 to put a full HD movie onto the ledger. So the person who is putting that content onto the ledger needs to make a decision whether having that content on the ledger is worth more than $5,000. And if it is, then this makes sense. Now, over time, as miners figure out cheaper and more efficient means of storing information, this value will get cheaper, and it eventually will fall to thousandths or millionths or even billionths of its current price, much as we've seen with spinning platter storage over the last 40 years. So I don't know if you guys have seen my talk on storage in Bitcoin, but I think it was back in about 1980. 1 gigabyte of hard drive storage cost $3 million. Now, 1 gigabyte of spinning platter storage is less than 1 cent for enterprise. So, that is almost a billion-fold, I think, or several hundred million-fold descent in price. So it's a pretty amazing leap in technology since in my lifetime, and I think we will see something similar to that in BSV. So do I think Bitcoin storage will be cheaper than traditional cloud storage? Actually, no, I don't. But I think what will be, systems will have the option. So basically you will get what like very, very similar to what you have with Dropbox today, and you'll be able to put your files in that. Those files will be secured with a hash. So you will be able to tell if any of those files have changed over time, but those files will not be stored on Bitcoin or on the ledger, I should say. But you'll have the option at any moment to put those files onto the ledger, but for the purposes of what you're doing, they'll just be stored either in local storage with an on-chain marker for data validation, or in the cloud, with a similar reliability and uptime to what we have with Dropbox today, but just not on Bitcoin. But you will have the option to pay that little bit extra to put it onto the ledger. I don't think it will ever be as cheap as traditional storage, but it doesn't serve the same purpose as traditional storage either. So now what I wanted to do next was to have a look at some valuable information, and just to show that it actually doesn't cost a whole lot of money if the data that you are putting onto the blockchain is rich enough. And so the example that I've chosen is Weather SV, and I really love what these guys have done. They've really captured the imagination of the Bitcoin SV community, and they are logging, I think, a set of data which is extremely important in the world today, with all of the arguments that we're having about climate change and whatever. Having a set of data that we can look at and know that it is unchanged from when it was logged, even 50, 100 years down the track, That's going to be hugely valuable when we are looking at climate patterns. We're starting to see lots of stories about how data sets have been changed by both sides of the camp. I'm not coming down on either side of climate change here. I'm just saying is what we need is honesty in reporting, and using this technology, we can bring that. So Weather SV is a very, very simple idea in its current incarnation. The site was set up to allow an individual to fund a channel in their hometown that logs weather data for that location. And at the beginning, it was $5 Australian. The price has dropped now to $3, of which Weather SV takes $1. And the remaining $2 is used to provide around 2 years of hourly weather data logged onto the blockchain. So, it's a pretty amazing service to me. I personally pay for half a dozen channels, including Brisbane, which is the one that's up on the screen at the moment. A lot of people agree. So currently there are 5,383 active channels on the map. A channel activation, just $3. From Weather SV, and they are currently looking at a plan to log all of the channels available on open weather data, which is around 22,000 channels, and they can do that for basically around $20,000 a year would be the cost to them. So currently looking for partners to potentially explore that, or looking at even opening it up to a public fund where anybody can donate, and that money goes to logging all locations that haven't specifically been funded by somebody. But so the interesting thing about this is that for an agency like a Bureau of Meteorology or something like that, the key difference in this scenario between what you would call a blockchain solution and using the Bitcoin public ledger is that if they go with blockchain, they are still the custodians of that data because they still own the blockchain. They have to power the blockchain. They have to provide access to that blockchain. It's still their property. And whereas if they use the Bitcoin public ledger, they simply provide the data to the miners who put it in a transaction. They can validate it, and then the burden of storing that data is no longer on them. So now they become much more focused on gathering correct data rather than housing years and years and years worth of data and providing access to that while ensuring that the validity of that data and the information contained within isn't being manipulated in any way. So by doing it with Bitcoin, they can walk away from that entire aspect of their job and become focused exclusively on gathering the best data and making sure that only the highest quality information is being pushed onto the ledger. So, and I mean, that is the case for any agency that is storing any kind of records, not just weather, but anything from legal, air quality, road usage information. All of this stuff can be put on chain, and the records now are on the ledger. And so the record keeping becomes something, becomes vastly simplified. So I like this function. Weather SV now offers a heat map view of the world. But the main reason I put this image up is because it shows that there are still very large areas that are not covered by the service. And presumably that a lot of these large areas aren't supported by Open Weather Map. So, I think there's a lot of work to be done in getting these remote regions supported with weather data. And I really do look forward to the day when all weather bureaus are logging their information and their data on the blockchain, on the public ledger. I think that's going to be a huge change for everybody. So I also wanted to cover a business solution. And today, I think the closest utility that we have that will be usable by enterprise is tokenized. And while I know people think, oh, well, it hasn't been released yet, there are actually enterprises who are out there building on tokenized. And I know for a fact that these businesses are not using it live in public yet, because the demand that they would generate is in excess of what we can reliably handle on the ledger today. So don't think for a second that tokenized is down and out. Those guys are building very hard, and I think they are really going to surprise a lot of people with what they release in, I don't want to say a short period of time, but whenever they get around to releasing it. So and importantly, what their system will allow for is for the complete structure of any company, business, or enterprise to be replicated as information on the ledger. So they can take the entire structure of a company, employees, everything, and put that into a structure on the blockchain. And that structure can then be updated whenever the company information changes. And so for a smart contract, you might only need to know the direct company. If you mark that manages a particular department, that would sit under that main smart contract, and then the people in that department would be listed in the subcontract. And so you can end up with this huge tree of contracts managed by entities. And in effect, you can replicate the reality of what's happening in a business or enterprise on the ledger. And I think that is the biggest thing that tokenized brings. And so again, we have this paradigm where if you tried to do that with blockchain, you would still be stuck in a scenario where you are running the blockchain, where you are hosting the data, where you are providing your customers, auditors, everybody access to that ledger. And where if you wanted to, you could still run a second set of books and behave in a dishonest manner. And this is one of the reasons that Satoshi created the Bitcoin ledger, is such that people could not run a separate set of books and put fraudulent information in public. And rather than having to keep paper copies of all of your business details, you can just now push all of that up onto the ledger. And only the most up-to-date information it will be current, but there's also the full history of all of the changes ever made to that company right back through history. Now, tokenized does support enterprise-level encryption, so obviously it's not going to be out there in public for everybody to read unless you do it in that way. So you will be able to put that information on the ledger with privacy, but be able to show it to whoever needs to see it. So that can be other members of the company, auditors, government, whatever. So now with tokenized, the major difference, so again, it's all about everything going onto the public ledger and removing the burden from the company of having to manage that information themselves. And while the tokenized smart contract agents are actually physical computers, the tokenized smart contract does not execute in Bitcoin script, is not managed by Bitcoin. It is separate logic running on its own computer that takes action based on the rules programmed into that smart contract. But the only means that you have of communicating with that smart contract is via the ledger. So there is literally not an IP address where you can go and hit that endpoint. So it makes it an extremely secure means of conducting business, because the only way that you can ask it a question is by publishing a transaction onto the ledger. And so if you want to make any change to your smart contract, or change the status of an asset, or pass it to somebody else, you must do that by making a request on the Bitcoin ledger. And if the smart contract agrees that your request is valid, so if you're trying to change the contract, if you're trying to move something, and the smart contract sees that you're breaking one of the rules that it has been programmed to uphold, it will reject your transaction. So There's a lot to like about this. I think from a company perspective, it means that handling tokens and things can be extremely simplified. And I think people are going to be very surprised at how fast they can build on tokenized and how simple it is to roll out. So, that's really the whole webinar. I do have time for some QA. As you can see, there is a lot to like when it comes to considering public ledger over a private blockchain. I really don't think there's any reason to use a private blockchain. I think the disadvantages that they bring far outweigh any perceived advantage that you might get. Now, a single public interface for everybody means that we can all be certain that what we're looking at is the honest truth. And the strong and improving stack of privacy techniques that we are getting on BSV will make this ability to warehouse data upfront really simple, really private. It'll allow people to monetize their information and more. So, I do have time for questions. So, I see Eckhard, you've unmuted yourself, so please go ahead.
Yeah, I just wanted to say a question. Not storage will be cheaper than traditional cloud.
Yep.
I think actually it may become cheaper than traditional cloud because first, every functionality that Bitcoin has already baked in, baked in is a bad word, but I mean like security, encryption, identity, these kind of things, which are on a global basis. Every cloud provider has to build on its own. So there's an efficiency gain. And then since this is we can see it as one global cloud, there are a lot of scaling efficiency gains. So I think it might actually become cheaper than traditional cloud storage.
Well, I think definitely it will be cheaper for people who don't necessarily need, so I think I pay Dropbox about $150 a year or something, and I get some stupid amount of data. I get, like a terabyte and a half or something like that. But I would use probably less than 1% of that. So the core difference between that is with Bitcoin is that you only pay for exactly what you use at the moment you use it to the byte, and you only ever pay once. So, with Dropbox, I get my 10 terabytes, but even if I don't use it, I still have to pay for it and have to pay for it every single year. And so, yes, longer term, definitely you can say that it is cheaper longer term, even today, to store, smaller amounts of data on the ledger, and definitely much more cost efficient. Yeah, but I think in terms of dollars per gigabyte, I don't think it will ever be cheaper to store it on chain as it will be to simply store it in cloud storage. But I think that the cloud storage will ultimately always cost longer because it's not a forever solution. You do have to pay, annually or monthly or whatever it is for that information to be kept there available for you.
Yeah, okay, but I mean, in Bitcoin, I think the jury is still out how long-term storage is going to be.
That's true.
Regarding pruning.
So you may have to pay. So if you lose your own local copy of your data that you've stored on Bitcoin, it is possible that you may have to pay some money to retrieve it again from the net. Whereas the difference with that and Dropbox is if you stop paying Dropbox and they lose it, it's gone. So gotta pick.
So one other aspect in terms of storage costs is, I mean, the miners will be highly specialized, okay? and
Yeah, very.
this drive costs down dramatically, I think. So I still think it can be cheaper than traditional cloud storage, but we'll see, hopefully.
Yeah. Well, I think it'll be cheaper eventually than what cloud storage is today, but by that time, cloud storage itself will be much cheaper as well. So, yeah, it's going to be, there'll be a bit of a race, but then eventually, I think that cloud storage will become much like hard drive storage in computers, and eventually, people are going to stop using their hard drives in favor. So, what's happened is like hard drives are actually getting smaller. People are getting these flash drives that have much smaller capacity, but they're just getting cloud storage, and they dump the vast bulk of their stuff in cloud, and they only access it when they need it. Well, so eventually we're going to go from a situation where the vast bulk of stuff is in cloud and a small proportion is on the ledger. So I used to have everything in my own hard drives and a subset on cloud. Now everything is on cloud and a subset is on my computer. Well, eventually we're going to have, it's going to go everything on cloud and a small subset on chain. But then over time, as the cost of being on chain, comes down and down and down, all of that's just going to get moved across. So basically everything will be on chain from a certain point. But it's very hard at this point to see where at point. But certainly the case can be made today that there are data sets out there that are more cost effective to be stored on chain than in a cloud storage system, simply by virtue of the fact that they then become far, far more accessible. The hosting cost of that information drops dramatically, all these sorts of things. So.
Okay. One other question. Yes,
Yep.
yes. Thank you. So how do you, so I understand the data storage part. Yeah, very good illustration with your airline thing example. How do you see, but a little bit what's missing for me, so tokens is fine, no problem. But I mean, cloud is not only data storage, it's also applications are running on the cloud. So, and I think Bitcoin as an application platform is a very interesting value proposition as well. Would you agree?
Yeah. So, I mean, eventually we're not there yet because we don't have the necessary expertise in programming in Bitcoin script for people to be able to move services that currently run on the cloud into a Bitcoin payment channel. But eventually that's what will happen, is that instead of reaching out to a website and providing it with some data and receiving a web page in response that has some answers to that data, what you'll actually do is open a payment channel with a computer somewhere. You'll feed it a script that you got from somewhere else with information that you sourced, and it will spit back an answer. And it won't know what it's calculating. It'll just spit back an answer, and it will actually be your device and you yourself who's putting all of those pieces together. And so I think that's going to be an interesting change when it happens, but I think we have a long way to go to get there. And I think that's going to be one of the toughest leaps. And I think certainly in the near term, yes, you are right in that cloud systems will still be needed. However, I think the nature of those are going to change, and we're going to start seeing it move onto much more planaria-like infrastructure where we have a cloud system that is operating on top of a subset of the ledger that it holds directly there. And being able to sort of separate the data storage and data security is actually going to simplify what those cloud systems will need to be as well. So I think that's something that people will realize a lot more quickly when they see how fast and easy it is to deploy fairly sophisticated projects using things like Run SV and Gear SV. These protocols that allow you to basically build software dynamically on the fly for any particular application. That's what you can't really do right now in cloud very easily, but we're going to be able to do that very, very easily in Bitcoin at like on a device level. So
yeah, exactly. That's what I meant. So I think it's a very attractive, and I think this could be. So we see this happening with apps like Twitch today. I think they have a very slim backend compared to Twitter, let's say. Yeah.
Yes.
The question is, will enterprises adopt this kind of Bitcoin-based architecture as well? So
I look at something like Twitch and I see they've got like 6 guys, and then I look at Twitter, they have like 6,000 guys, and I think that the sheer weight and the sheer difference in development paradigms is going to force everybody to look at this very thin type of infrastructure and how to make it work for them.
Yeah.
I can't see, I honestly don't understand all of employees. Most, they're working out algorithms to show you the best ads. Like literally that's what they do, because that is how they make their money. Which is why I like Twitch so much, because they make their money by actually providing you the service that you're using. So Twitter is monetizing you by providing you as a service to somebody else.
Yeah. Agreed. No more questions, Your Honor.
No worries. Dirk. Thank you, Eckhard. Dirk.
Yeah. Can you hear me?
Yes, I can hear you.
Okay. I have a question regarding the Merkle root. You have mentioned it before.
Yes.
And if in the mining process, the miner is changing the nonce, but this is not sufficient to get it difficult to get the right hash, and therefore the miner has also to change the extra nonce in the Coinbase transaction, which means that the Merkle tree and the Merkle root must be recalculated beginning from the beginning. I think that's quite expensive.
So actually that's not quite the case. So a Merkle tree is actually additive. So you can take the first part of the data and you can generate a Merkle root for that. And you can then take another piece of data and calculate a Merkle root for that. And then you can actually then join those together with just one hash. You don't need to rehash everything again from the beginning. So what the miners are actually doing when they change the extra nonce, which is actually a field inside the Coinbase transaction, the only thing that is having to be recalculated when they do that is the very last hash in the Merkle tree and the very last sort of string of hashes following the Merkle path back up to the root. So, even if they had, say they had 4 billion transactions in a block, they would literally only have to calculate 32 hashes every time they update that extra nonce field. So they don't have to do the whole tree.
Yeah, I would do it the same way, but I have read about it that the tree starting with the Coinbase transaction is left leaf at the bottom, and therefore I thought we must recalculate every single aspect of the tree.
No. The Coinbase is the very last transaction on the tree.
Yeah, that's perfect. So it's also, if you think about separating hash functionalities, so that, for example, in China, where lots of hash power is available, and they get the transaction from another country and then start the mining process. It's not necessary to get in between more information from the other country.
Yeah. So what you're going to start seeing happen is, so miners will deal in batches of transactions. So that they'll get a million transactions. They'll build a Merkle tree. They'll sort of, and what also is happening right now is with the development of Terranode, is that the actual hardware of a mining node is being split out into multiple different pieces of hardware. And so what you're going to have is one computer that's there that's actually bringing transactions in off the network and validating them. And it then passes them into a bundler, and the bundler takes those transactions and it, takes them in like blocks of whatever, say 64,000 transactions, puts them all together, calculates a Merkle root for that block of transactions, and passes that down to a Merkle tree builder. And maybe that Merkle tree builder takes 10 of those blocks of 64,000, calculates a root for that, and then sends that out to the miners with the Coinbase transaction in it and says, well, here's a new block template. And so the miners would start hashing on that block template. While that's happening, more transactions come in, they get new batches, they build a new, bigger Merkle tree with more transactions and more fees in it. They go back out to their miners and they say, hey, here's an updated mining template for trying to find a solution for this one. And so it's always in the miner's interest to be mining on the template that has the most transactions, has the most fees in it. And what you're actually going to start seeing, I think, is a lot of dynamic hash, where the hash is not just moving from template to template for the same miner, but you've actually got hash that isn't controlled by a mining node, but by a separate entity who has agreements with many different mining nodes, and will just be picking the one which at any given moment is offering them the most money for their hash. So it's going to get really interesting, because there's this whole dynamic mining system, and with the Stackelberg game, it's going to get really interesting. This is a tremendous field for research and development, which I think there's just a few very small players who are running away with the whole market at the moment. Nobody really understands this properly, and I think the ones that do are the ones who are going to be mopping up the blood at the end of 2020. I can tell you that.
Yeah. Okay, thanks.
Yeah, no worries.